everyone. Welcome back to my math teaching online. In this video, I will show you how to sketch the polar curves. And before I get into the topic, please let me show you my website. If you visit my mathteaching.ca, you can have a weekly lesson plan learning and maybe read some beautiful poems and beautiful videos of interesting pictures I post there to help you relax, enjoy beside of your learning math. Otherwise, you also can, if you like the way I teach, please purchase the full set of course online, Introduction to Calculus. Go to mathcourses-online.teachable.com. Our course creator, would like to share our passion to audience, would like to love what we do and love to share with you. Also, I believe that education is not about the school. Education is about how an individual can obtain the same knowledge, the same skill, comprehend it, and use it wisely for your future benefit and contribute to our society. So that is education about. Education is not about private school or public school. You can pay a fortune for a private school, or you can learn a free lesson online from YouTube. The important point is you understand and comprehend the topics. So we are course creator. We try to make our course attractive, easy to understand, and meaningful to contribute to our global education. For free online education, we spend any of our penny of saving to try to purchase this platform, teachable.com and wordpress.com, to build our course. So in order to have energy keep going, we just ask for a little bit of donation for everybody to show your appreciation if you benefit from it. And thank you for contribute to our global education. Thanks to the YouTube have given us the opportunity for us to have a chance to do what we love and to share our passion to all the audience around the world. Anyway, let me get back to the topic. So I'm going to show you how to draw the polar curve r equal 3 sine theta. Now we have a unit circle. I have shown you how to draw it, unit circle, and scale it in the previous video. So I will not go through this diagram anymore in this video, but I will use it. So before we plot any curve, we always have to know the value of the coordinates to plot it, right? So on the polar curve, we have two values, which is the radius and the angle theta. That's the polar coordinate, right? Instead of x and y, like the Cartesian coordinate. So we're going to use this one, radius and value of theta. So let's calculate them so that we can plot it. So I'm going to say start from 0, right? If theta equals 0, we always start from 0, right? Always start from that. If theta equals 0, then what happened? R will be equal to times sine 3 times 0. Make sure we know the 3 here, right? We have a 3 as well. So sine 3, 0 is just sine 0. And sine of 0 will be, this is, if you learn trigonometry, you know all of the coordinate, typical coordinate, you should remember, right? So this is 1 and 0, this is minus 1, 0, and this 0 and 1, and this is 0 and minus 1. And the first one stands for cos, the second stands for sine. So sine of 3 times 0 is sine of 0. Sine of 0 is 0. So that will be 2 times 0 and equal 0. So if theta equal pi over 6, let's say pi over 6, then our R will be equal pi over 6. R 2 times sine 3 times with pi over 6. And that will cancel the 3 with the 6 down here. So this angle will become pi over 2, right? Instead of 3 pi over 6 will become pi over 2. And this will be equal to 2 times with sine pi over 2 is 1. So that becomes 2. So we're going to frame it so we know the angle and we know the radius. So if theta equal pi over 6, now let's go to pi over 4. Then R will be equal to 2 times sine of 3 times pi over 4. Now 3 pi over 4 will give us 1 pi over 4 is 1 over square root 2. So this will be 2 times with sine of 3 pi over 4. 3 pi over 4, actually this way, the angle this way, right? You see the angle. So same thing, the value the same. So 2 times with 1 over square root 2, which is become 2 over square root 2. And 2 over square root 2 is 1 over 4. That's value. Okay, so theta equal pi over 4 now. Let's go to pi over 3. If theta equal pi over 3, R equal 2 times sine pi over 3 pi over 3, right? 3 pi over 3. Now 3 times pi over 3 cancel, turn out to be sine pi. And sine pi is minus 1. So that will be equal minus 2. 2 times minus 1 is minus 2. So if theta equal pi over 3, now go to pi over 2, R will be equal to 2 times sine of 3 times pi over 2. And pi over 2 is, sine of it is 1. So 3 times 1 is 3. Wait a minute, what I'm doing, yeah. So 3 pi over 2. 3 pi over 2 is down here, right? 3 pi over 2. Sine of 3 pi over 2 is minus 1. So 2 times minus 1, 2 times minus 1 is minus 2 again. Let me see if I make any mistake. So theta equal pi over 3, I equal 2 sine 3 pi over 3 cancel. We have sine pi. Sine pi is 0. Oh, okay. So sine pi, so we have to be careful. I'm going to rewrite it, okay? So sine 3 pi over, wait a minute, where we go? 2 times sine 3 pi over 4. And 3 times pi over 3, which is this one. So pi over 3. So we cancel the 3, so that equals 2 times sine with pi, which equals 2 times pi is 0. So this equals 0. Okay. So if theta equals pi over 2, equals 2 sine 3 pi over 2. 3 pi over 2 down here, so minus 2, that's right. So now if theta equals pi over 2. Now, let's go to 2 pi over 3. 2 pi over 3 will become 2 times sine 3, right? We have a 3 in front, 3, and theta is 2 pi over 3. So again, this will cancel with 2 times sine 2 pi. And sine 2 pi is 0, so equal 0. Now, if theta equal 3 pi over 4, then R will be equal to 2 times sine 3 times 3 pi over 4. So this value will be give us 2 times sine of 3 pi over 4, which is 9 pi over 4. 9 pi over 4. Yeah, so it will be 2, right? Times with sine of 9 pi over 4. Now, 9 pi over 4, 9 pi over 4. So we have 3 pi over 4 this way. We have 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 7 pi over 4, 8 pi over 4 this way, right? See 8 pi over 4. So 9 pi over 4 back into this value, right? You see 8 pi over 4, 9 pi over 4. So the same like pi over 4, right? So will be equal 2 times sine 9 pi over 4, right? In here is 8 pi over 4, which is 2 pi, and this is 9 pi over 4. So the same like 2 times sine with 1 pi over 4, right? So I'm going to change this into 1 pi over 4. The same like 9 4, right? I'm going to put here same like 9 pi over 4, which is 2 times with 1 over square root 2. And 2 times with 1 over square root 2, this is 1.4. And that is still positive value, right? This value is 1.4, okay? Mark it here. Now, if theta equal 3 pi over 4, 5 pi over 6, what did happen? For 5 pi over 6, will be equal 2 times sine of 3 times with 5 pi over 6. We can cancel that, and that equal 2 times sine 5 pi over 2, right? Because cancel this with that, so 5 pi over 2. Now 1 pi over 2 is here, 2 pi over 2 is here, 3 pi over 2 is here, 4 pi over 2, 5 pi over 2 back in there. So the same like 2 times with sine pi 5 over 2, sine pi 5 over 2, here is 0 and 1, so 2 times 1 equal 2. So back in 2, right? Theta equal 5 over 6 equal pi, then R will be equal to times sine 3 pi, right? Because sine, 3 pi. Now 1 pi is minus 1 and 0, so 0. At 3 pi, the same thing. You see 1 pi, back in here is 2 pi, and 3 pi back in the same position, right? So that is 2 times 0, which is 0. Right? You see what I mean, right? Sine 3 pi, so here is 1 pi. Back here 2 pi, back here 3 pi. So the same position, which is 0. So theta equal pi. Okay, so let, I don't know what should we plot this first. Okay, let's continue. So pi, now let's do down here. Let's go to pi 5. I'm going to skip this one, right? I'm going to go to 5 pi over 4. So if theta equals 5 pi over 4, what happened? 5 pi over 4 will be equal to 2 times sine of 3 times 5 pi over 4. Which is 15 pi over 4. When 2 times sine of 15 pi over 4. Now you wonder, you will say, oh, why too big, right? But just remember like this. You have a 1 rotation is 2 pi. So 2 rotation will be 4 pi, 3 rotation will be 6 pi, and 4 rotation will be 8 pi. So 5 rotation will be 2 pi times with 5, which is 10 pi. 10 pi is 5 rotation. And 6 rotation will be 12 pi. So 6 rotation, you have 12 pi. So 7 rotation, you have 14 pi. So after 14 pi rotation, you get back to pi over 4. So I mean, if the 15 pi over 4, consider like pi over 4, right? So consider like pi over 4, which is sine of pi over 4 is 1. 1 times 2 is 2. So this value the same like number 2. Okay, so that's the idea if you come up with a big number like that. Okay, so now let's plot this a little bit, and then we might finish the rest by guessing. Or not guessing. It usually mirror, right? Coordinate mirror by mirror. Okay, so let's plot this first. So if theta is 0, because this is trace our method. So if theta is 0, we start from 0, right? If theta is pi over 6, the answer radius is 2. So let's plot this radius, which is right here. Let's mark this is 1 and this is 2. Maybe make it shorter a little bit. Not destroy this coordinate. Okay, so let's say this is 1 and 1 scale, now 2 scales here. So pi over 6, that's the point. And let's mark it at 2 here. And pi over 4 is 1.4. So 1.4 is less than, it's almost like 1/2, right? 1.5. So it's about here, 1.4. And if theta equals pi over 3, the answer is 0. So pi over 3, it go back to 0. So the first, like this, right? And then go to here, and go to 0. So that's the first pattern we can plot it. So we start from 0, we go to 2, right? We go to 2, and we go to 1.4, and we go back to 0. That's the first pattern. So now, so pi over 3 is go to 0. Pi over 2 is -2. So when it go to pi over 2, the radius -2. So it's backward, right? So instead of moving forward is 2, we go backward this way. And the scale here is -1. and down here is minus 2. So for pi over 2, we will, instead of go like this, we have to go backwards this way, right? That's pi over 2. So now 2 pi over 3 is become 0. So from here, if we go to pi over 3, we go this way, and it's back to 0. Okay, and then when it go to 3 pi over 4, it's 1.4. So 3 pi over 4, which is this line, and 1 is here, 2 is here, so 3 pi over 4 about here. So this way, right? This curve. Now, when it go to 5 pi over 6, the answer is 2. So pi over 6, the answer is 2. So this is 1 and this is 2. So this is 2, right? This line rapid. So it go up to here. 5 pi over 6. And when we go to pi, it go back to 0. So this is the curve look like. So we have the 3 petals for this curve, r equal to sine 3 theta. So that's how you sketch the polar curve. You can see that I did a very slowly like process and formal how we sketch them, and it's become a shape look like that. Because I want to show you the whole process of how we sketch it formally, but we also have a short way of how to do it, and I will show you in general, right? I'm not going to go to sketch each curves, but I will go to in general how to sketch it when we're using the short way of doing it in the next video. And I will just give you another video where we end this bonus section. I call it bonus section because this is in the first year of your university calculus course, not in Math 12 calculus course. Therefore, I call it bonus section. And therefore, I don't require you to go to the unit quiz for this section in my calculus course online. I just provide you the knowledge so that you get yourself be familiar with the materials, with the course, so you don't get the culture shock in the university when you learn it in 4 or 5 courses in university. You didn't have time to research a lot, right, for each subject. So I provide you the tools to help you to go through the education in a much easier way than the way we learned it 20 years ago. To be honest, I wish I was born in this generation so that I can learn the free education online on YouTube rather than try to figure out, like, and sometimes we could not figure it out and we got stuck. We just try to pass through the course hurriedly, and we miss a lot, to be honest with you. It's very helpful when you learn in this period of time, in this generation. You are provide all the good tools from all the educators, course creators around the world, like us, or like from your teachers in the classroom. But beside that, you have the tools to help you progress more easily. So take advantage of it, right? I wish you on success. And thanks for watching, and bye for now.